Had I known that that intro was going to be rather loud, I would have definitely changed that. But I know that this talk is going to be one of your last few before lunch, so let's get started right away. I don't want to waste any time. And first things, show of hand. How many of you have heard of Observability 1.0, 2.0, 3.0? Come on, share. Oh, that's very good. I'm so pleased that very few of you have heard of them, because after this talk, you're definitely going to know what they mean. You're going to have opinions about them if you don't already. And I also have a fun game for you. Try to guess how many times I'm going to be saying observability throughout this session. There is going to be a quiz at the end. Okay, so as you may have guessed, the observability world has been abuzz with versioning the term observability. And my objective is to spark some conversations about other use cases for observability other than just monitoring production for downtime. So we're going to look into how we got here, how it affects developers, and also how you can adapt your team's approach to observability into all of these new versions. So I don't have to introduce myself. I'm just going to say that at Multiplayer, most of our job is working with teams who work on distributed systems. We help them debug them. And so as you can imagine, I spend a lot of my time in observability land, and that's where my knowledge and scars come from. Okay, so as a starting point, we're going to take a quick stroll through the history of observability, because to know where we're going, how it's shifting, it's helpful to know how we got here. And maybe this is going to be an opportunity for you to see where your team fits in or where you'd like to see your team go next. And so let's dive in. This is going to be a tale of logs, metrics, traces, and drama. So let's get started. In the 1990s, with the rise of internet era giants like Amazon, Google, and Yahoo, we saw the emergence of truly large-scale distributed systems. These systems brought new levels of complexity. I'm so pleased that some of you may recognize this dashboard, right? Such fond memories. Um, so lots of complexity, but there is a growing need to understand performance, reliability, failure modes across many interconnected components. And this need means that the engineers begin instrumenting their systems with the core signals that we still use today, right? We are using logs to capture what happened, metrics to quantify behavior over time, and actually slightly later, distributed traces to follow requests across services. But at the time, this was called monitoring, right? We are checking for known issues, and we are mostly setting up alerts for when things broke down. But then 2010s, everything changed, right? Architecture shifted dramatically with cloud native technologies. Now we have microservices, containers, ephemeral infrastructure. All of that brought scale, speed, and a lot more complexity. And at the same time, we have this boom into the telemetry ecosystem. We have Grafana, Prometheus, Elasticsearch, Open Tracing, Open Census, which then became OpenTelemetry. And so engineers are emitting massive volumes of telemetry data, often without any regard to cost. And we started to realize that monitoring is great for system health, but we need something deeper to understand what's going on in some of the black boxes that these systems had become. So this is where we start to talk about observability as something else beyond monitoring. And in 2017, Peter Bergon, a software engineer focused on distributed systems, wrote a really interesting article, and he identified observability as three pillars: logs, metrics, and traces. Now, this definition caught fire, especially with the APM tooling world, because coincidentally, it aligned perfectly with their product offerings. And so let's talk a little bit more about this version of observability, which is sometimes called Observability 1.0. And it's really not just three pillars. That's so misleading because teams use many different tools. Just think of your own teams, right? You have APM tools like New Relic and Datadog, and then you have Grafana for infrastructure log, tracing, Jaeger, SLO dashboards, SLO trackers, RUM tools. Pentry, Posthog. Maybe you have product analytics, marketing analytics, many things. And all of these tools, well, they process their and store these data in their own unique formats, right? You have time series databases, columnar databases, maybe log files, proprietary systems. It's not just three things, it's many things. And all of these tools, what they're doing, they're monitoring for known unknowns, right? These are anticipated failures. You know something's going to go wrong, you just don't know when. And so you're predicting what kind of issues that are going to happen, high latency, error rate spikes, and then the data that you're going to need to diagnose those issues. So that then in advance, you can collect that data, you can set up thresholds for what bad looks like, and you can set up the dashboards to visualize this data. So effectively, all I'm trying to say is that this is very reactive. You decide what are the questions that you want to ask, and then you set up your tools to answer those questions. And also, that's also why it's so great at detecting health and trend spotting. But another characteristic is that this is the realm of a very specific group of people. These are ops, DevOps, platform engineers. And another characteristic, again, is cost. There was a very interesting Gartner webinar that I recommend that you check about the exponential rise in observability costs. And they brought as an example one of their customers who had a 50K bill with a single vendor. And remember, companies have multiple vendors for observability in 2009. 2024, this was already 14 million, which again is not that bad if you remember that Coinbase paid 63 million to Datadog that 1 year, right? And there are many reasons why observability costs may be skyrocketing. We have digitalization of businesses, the organic growth of your business. And so as your business grows, so does the data, so does your complexity of your architecture, infrastructure, application. And it's not uncommon for teams to ingest hundreds of terabytes of telemetry data daily, and some are going up to petabytes. And obviously we have tool sprawl. I talked a little bit about that, but the more context and detail you have about your data, well, the higher the cardinality and dimensionality of your data, the more you end up paying. The problem is that you're paying so much money, but at the end of the day, you don't really know how useful all of that data is. How much of that data is being used by your team to understand, to debug. Well, what ends up happening usually is that you then try to keep costs down. How do you do that? Well, you try to reduce your tool sprawl, or you adjust the cardinality threshold. You pre-aggregate your metrics, you sample your traces. The result is that you're losing that detail that you need to understand your system, or you waste engineering time just trying to find a balance between I need to have enough data to understand my system, but not too much so that I don't go bankrupt. So going back to that history lesson, while we were having this discussion about the three pillars of observability, charity majors, Ben Siegelman, and other thought leaders, well, they tried to clarify the difference between monitoring, telemetry, and observability. And the idea here is that observability extends beyond traditional monitoring. It's about introspecting and investigating complex systems. Issues in distributed systems are rarely linear. They're very hard to predict and they're rarely isolated. It's really, really hard and impossible actually to anticipate every potential failure and create a dashboard for that. And so the objective of observability is to understand the unknown unknowns. It's not enough to know that there is an issue. You want to know why and how that happened and how you can prevent it in the future from happening. By the way, I also hope that you appreciate that I tried to draw a scientifically accurate iceberg floating in a stable position. Didn't turn out that well, but anyway, going back to then that history lesson last year in August, Charity Major, co-founder of Honeycomb, wrote this article. And she argues that we are undergoing a social technical sea change. And that's why the term observability deserves to be versioned. Companies are changing how they approach observability, both from a technical standpoint, but also from in how teams behave and how they use observability. And that's why it should be observability 2.0. So let's look into that. Now, her main technical argument is that instead of having multiple sources of truth, you should have a single source of truth that is consistent, uniform in both storage and format. Now, any structured, high cardinality event data stored in a single place would do for the purposes of this definition, although wide structured logs are particularly well suited for that. And you can derive all other data from that single source of truth. You can derive your metrics, your traces. And in other words, what she's saying is you don't need to know all of the questions in advance and then set up your dashboards to answer those questions. Even if you don't know the questions at runtime, you're going to be able to find the answers later on. Obviously, the cost will depend on how much your company grows, on the complexity of your architecture. But with this model, well, you have fewer tools, right? And you're also saving time engineers in finding those unforeseen, unpredictable, unknown unknowns because they can do that faster. In a distributed system, understanding what went wrong, why, and how usually requires correlating data across many different layers, which is time consuming, error prone, especially because you have to pinpoint exactly data points or interactions that happen that can get lost if you're working with pre-aggregated results or if you have to correlate them across many different tools. So um, this approach, as you may have guessed, is much more proactive. It's more effective when it comes to debugging, but you also have more confidence in working with your systems because now you can understand them better. And finally, it's not just DevOps anymore. You can extend these tools to the larger team throughout the entire software development lifecycle. That Gartner webinar that I mentioned before had a really interesting tidbit about one of the factors that causes observability costs to be so high, and that's because when teams start to use them, they want to continue to use them. And that makes perfect sense to me, to be honest, because our systems have gotten so complex that the old ways of understanding them just don't cut it anymore. Previously, you can go just to a whiteboard with a Sharpie and start drawing out your system architecture from memory, and there was a high chance that that was going to be perfectly accurate. Today, not so much. In fact, when you have hundreds of microservices and APIs and dependencies, nobody's keeping all of that information in their head. You don't have a full mental model of all of that. And by the way, I want to mention that not every team leans as heavily into each one of the items of this definition. Some people emphasize a little bit more the single source of truth, like charity majors. Others emphasize more the fact that you can extend observability to the larger team. Okay, second to last item on the history journey. In December of last year, Hazel Wickley, a senior lead software engineer, proposed another version of Observability 3.0. Now, her premise is that when engineers have access to the tools to ask meaningful questions of their systems, well, that's the same data that all of the other teams are using, right? Think of business forecasting, marketing segmentation, product analytics. So right now you have all of this fragmented data across tools and teams, but what if it weren't? What if we unified all of these workflows so that everyone, engineers and non-engineers, could have access to this data, could understand their systems and act on that knowledge? Well, she's saying that the next big cultural shift is going to be bridging the gap between observability and business intelligence. Fair. But here's a twist. Of March of this year, Matt Klein suggested a different definition for Observability 3.0 because he's saying that even if you have that single data format and storage, right, per Observability 2.0, and so you have this detailed telemetry to help you understand your system, well, you still have to send everything you're ever going to need ahead of time, which is still a lot of data and it's a significant cost. And it's inevitable that you're going to have some unnecessary noise. And so what happens is that you go back to that vicious cycle of, oh, I'm going to try to manage my costs. I'm going to now start managing sampling. And so your engineers spend time managing sampling. And now you question the value of every log and field that you're emitting. You start to limit them and you start to have less visibility. Instead, he proposes to capture everything locally on the user's device and only send telemetry when specific error conditions or patterns are detected, based on smart rules that developers could set. So that was a lot. We went from monitoring to Observability 3.0, and there are going to be more versions, more definitions, more hot takes, I'm certain. And maybe you recognized where your team fits in. Maybe you saw where you'd like to be in the future. But one thing is clear. We all want the same thing. We are chasing the same goal. We want to understand our systems better. And this is where we come in with the concept of shifting observability. And it's not a new concept. If you think back a couple of years ago, you started to see articles and talks about this topic, and yet we are still talking about it in different terms, yes, but the underlying concept is the same. Shifting left means giving developers more power. Shifting observability left means bringing observability tooling within the developer workflows earlier. So maybe shifting isn't exactly the right term because we're not moving the ownership of observability from one place to another. We're just expanding it or extending it. So maybe that would be a better term. And I think the best way to show you how this affects your teams is to give you some examples of what it means not to have observability earlier in the software development lifecycle. So we're going to start with not having an observability in pre-prod. And now, perfectly aware that larger organizations and regulated industries have observability across all of their environments, but many teams still don't have it in development or staging. And when that happens, there are three main challenges that they're going to encounter. The very first one, well, they're going to be unable to effectively troubleshoot pre-prod. When something breaks in staging, you're flying blind because without observability, there's no way to trace requests, inspect service interactions, in general, just debug failures efficiently. You have longer feedback loops, longer release cycles. Another problem is that you're unable to spot unexpected behavior before production, right? Because not seeing a failure doesn't mean that everything is working as expected. If you don't have observability, well, you miss the quiet failures, the unintended side effect, the inefficient flows. All of these things are not going to throw out any errors, but they are going to affect the user experience or your system's performance in production. And so you're also missing on untested edge cases because usually test fits, they validate expected behavior, right? Not the weird stuff that pops up. So without observability, you can't see the gaps in your test coverage until it's too late. And I don't necessarily have to tell you this, but just as a reminder, fixing issues earlier into the development lifecycle, well, it's so much more cost effective, right? There was this IBM study that found that fixing issues later in each one of the later stages just increases the cost by many factors. So, very last challenge when it comes to pre-prod. Without observability into both staging and prod, you can't identify environment drift, right? You can't see the differences in config, traffic, infra. Observability lets you validate not just functionality, but consistency across environments. And I'm just to bring this home, I have an example from one of our users of how they didn't have observability in pre-prod. Now, this is an investment bank and their engineering team shipped a new feature for an internal finance tool that their traders were using to calculate volatility. And previously to this feature, volatility was calculated on a minute-by-minute basis, and now their traders could select a custom time frame and could say, calculate volatility based on these timestamps. And everything looked great. Everything looked great in dev, QA, regression tests. They shipped it. And then one of their traders comes back and says, something weird is going on. The market is still open and you're showing me volatility 0 after 12 p.m. That doesn't look right. And maybe this is an example that stuck in my mind because they spent hours debugging this. They checked the upstream data providers, they checked the front end. And last, they found that this was a mismatch between time zones, between prod and pre-prod. Yes, it was that simple. It was introduced by the new windowing logic. The new logic enforced the user local time zone, which showed no errors in dev or pre-prod, well, because the systems were all configured based on the developer's time zone. But prod was using a different time zone. And so the new logic made it so that the volatility was calculated on after market hours. No alerts were triggered, well, because HTTP responses were still 200 and we just empty array responses, right? So no alerts. This is an example of having observability in pre-prod, where we would have identified the drifting environments, but it's also an example of having observability 2.0 tooling in prod. Because imagine having a way to identify these issues more quickly. If you had a deep session replay that correlated front-end with back-end data, you would have immediately seen the user switch to custom intervals, the change in the graph behavior after 12 p.m., and the quiet failure, pointing to the time zone logic as the likely culprit. Okay, so this is perfect segue, unintentional, for me to talk about production environments. Okay, and look, I know that many teams have three pillars of observability set up and managed by their ops teams in production, but what happens when you don't have the deeper insights provided by Observability 2.0 tooling, especially for the larger team? So challenging root cause analysis is one of them. So Observability 1.0, excellent for monitoring health and detecting known issues. Not so great when you have to do deep developer-led debugging, because usually when you have many microservices and APIs, you need more context, more detail than pre-aggregated metrics or sample traces can support. And it's also an issue of having to correlate data across many different tools, across the back end, the front end. Another issue that very much related to the first one is that when observability is only available to a specific team or ops, SREs, platform teams, the people writing the code, well, they lack direct visibility into how it behaves in production. So this creates a dependency loop. Developers wait on someone else to investigate, interpret, and grant access to telemetry. It slows down things, essentially, creates more communication overhead. Okay. Um, Second to last, I promise, limited support for unknown unknowns. Distributed systems, as we said, don't fail predictably. When something breaks, it's in an unexpected way. I know, think back to your own systems. It's a misconfiguration. It's a flaky downstream dependency. It's a rare concurrency issue. There is no alert. There is no signal. You only have a vague symptom that likely your end users end up telling you about. And also, you miss low frequency but high impact events. Sampling and aggregation help manage costs, but they also cut out rare but important events. Now, imagine that you have a bug, and that bug affects only the 0.01% of your users. That's going to be completely invisible in pre-aggregated metrics or dropped entirely due to sampling. But what if that 0.01% of your users is one of your biggest enterprise users? You want to see that bug before they see it. And to catch that, you have to have fine-grained data that surfaces anomalies in the long tail. Okay. So what do? Right? You're troubleshooting quietly failing features in pre-production, or you're chasing intermittent bugs in prod. Well, again, same common thread. You need more visibility sooner. This is where OpenTelemetry comes in. OpenTelemetry is underpinning much of the progress both in traditional and in the emergent observability field, and it's born out of this need to move past the fragmented proprietary tooling and provide you with a vendor neutral, open source, common language and tool set way to generate and collect logs, metrics, and traces regardless of your tech stack. And OpenTelemetry adoption is actually really widespread now. I know when I checked, it was more than 1,000 companies. It had hundreds of contributors. But to really get the most value from it, you need to go beyond the defaults. So I have a set of tips. I ran them by my team. They graded them. They gave me comments. They weren't always super happy about my suggestions, but I'm just going to share them with you. Now, the first one is to use lightweight local exporters instead of a full observability platform in development. It's a basic tip. Yes, that's also why I got a 2 on the score. But you can just use OpenTelemetry SDK to output telemetry data as logs printed to the console. It's as simple as that. It's great for debugging locally. You don't need any infrastructure or dashboards. Next tip is to increase sampling to catch more details in dev. Another common knowledge tip, but developers often forget that you can override sampling rates locally. It's a medium effort, high return type of tweak. Production sampling usually is 10 to 20%, and when dev instances are run, you can temporarily increase it to 100%, so you catch those bottlenecks or edge case failures. Next tip, to reduce environment drift, traces can be tagged with environment metadata using attribute key. This enforces view of trace origin, reduces noise. It's just a quick win to make querying and comparisons across environments that much easier. Replay user traffic in dev. Extraordinary tip, but I know engineers know load testing, but very few actually extract real traces from prod and then use those traces to simulate traffic in dev using load testing tools, for example, like Grafana K6, which supports the OpenTelemetry metrics format. And this is a powerful technique to reveal some bugs that you wouldn't otherwise know about. Although, obviously, I caution you to use it carefully because production data could be sensitive. Next one is to use deep session replays to capture full stack context during debugging. Now, while recording sessions is not new, right? You have RUM tools, you have screen recorders, many of these things. Tying front-end behavior with back-end traces, logs, and metrics in a single timeline is a time saver. Not every tool does that. It removes the guesswork between correlating user actions with system behavior, and especially in distributed systems where you have to span many different services. Second to last tip, I promise, only 2 more. Auto-generated test scripts from debugging sessions. Most teams manually write test scripts after an incident. Having a tool that turns real bugs into testable, reproducible test scripts automatically saves you a lot of time and helps you build better regression coverage. Very last one. Now, some of you may be using AI IDs like Copilot and Cursor, and they're great when they're supporting you in generating code. They may struggle with complex debugging, right? Because they lack that full stack context, the runtime context. So if you want actionable fix suggestions, you may want to feed them data from debugging sessions that, again, correlate front end and back end. They need to have all of the user steps, the API calls, the traces, logs, metrics, the failure path, like all of that contextual information. Okay. I know I'm almost at time. So since I mentioned AI, I cannot but have one slide. One. This could be a whole talk in itself, but many engineers are exploring how to integrate AI in your daily workflows, in your technology strategy, and that's smart. But AI doesn't magically fix bad visibility. You've heard the phrase garbage in, garbage out. Well, it applies in this case as well. If your systems are a black box, if your telemetry is sparse, sampled, missing context, well, AI is not really going to help that much with that. You're just going to have faster guesses with poor input. But if you shift observability left, if you invest in rich real-time telemetry that connects across environments, across teams, across layers, well, then AI can become a powerful amplifier. Okay, I'm going to wrap it up. I have 1 minute. So shifting observability left, bringing it in pre-prod, expanding to the entire team. So effectively bringing it earlier into the software development lifecycle. It's not just about catching bugs early, although it very much is about catching bugs. But it's also about how we build, ship, and support software. It's about understanding system architecture in real time, validating assumptions, and shortening the time between writing the code and understanding its impact. So, last final inspirational sentence. Shifting observability left isn't just a technical choice, it's a strategic one. The systems that we build today are too complex to fly blind until production, and engineering time is too valuable to be used guessing. So, thank you for listening to my talk.